All right, so here's the first thing we're going to talk about today. So, what do you need to write and what do you not need to write? That's the question you want right now. That's the question you want answered. You do not need to write this whole big paragraph before the bullets. What I do want you to write instead is this. Assume. I will be reading this paragraph out loud. So, we want to prove the angle properties we've used before, but we can't do that from knowing nothing. The following properties will be assumed as true, and together with algebraic properties will be used to prove all other properties. All right? So a lot of this stuff you should actually probably have in your notes already. If you don't, here's what I recommend right now. Try messing around with a little bit of shorthand. Have you guys heard about what shorthand is? Shorthand is when you try to make everything shorter in writing than what you heard, as long as you can understand what it means. For example, this first point says, an entire rotation around a point or a circle measures 360 degrees. I might write this. Everything is around 360. If I can look back at it and understand what it means, then it's good notes, right? Eventually you might develop a system for yourself that makes it easier to write stuff down instead of writing down every single word here. If that helps you, cool. If it doesn't, just don't worry about it at all. But these are the assumptions we're making. We're saying that everything around a point measures 360 degrees, supplementary angles add to 180, complementary angles add to 90, and so on. So these are the assumptions we're making today. If you feel confident in all of these materials and you have them in your notes, then no. You feel great about them. This last one we are going to write down something though, but I haven't actually given you what it says. So I'm going to give a second for people that are writing this that want all of this as, you know, a new thing here.
Can you read all of them?
Can I read them?
Yeah, I can see it. I'm blind.
How are you so blind? You need glasses, man?
Yeah, I forgot it.
Oh.
I used them and I forgot it.
Oh my gosh. So the first one, an entire rotation around a point or circle measures 360 degrees. Rotation around a point measures 360. Next one is that supplementary angles add to 180. The next one is the definition of complementary angles, and that just says that they add to 90 degrees. Complementary angles add to 90 degrees. And then when lines are parallel, corresponding angles are congruent. That's a big one. That's a big one we're going to use today. So here's my question at the end though. If this is the stuff we got at our disposal, if these are the tools in our tool chest, plus algebraic properties, and also plus some of the segment stuff that we talked about, the transitive property, the substitution property, the reflective property. Reflexive, sorry, yeah. Yeah. Little known secret, I'm actually a little bit dyslexic. I had trouble reading when I was in high school, actually. So, you'll see that a little bit in my English. It's not fantastic. I can read fine now, but, you know, it wasn't a great time for me in the reading department, yeah. You guys know when you go around that circle and you, like, read the paragraph, you have to, like, read it out loud in middle school? I hated that so much. I hated that.
Everybody does.
I usually left the room, actually, when I was in middle school. Yeah. Okay, so if we have this stuff, if we have supplementary angles, if we have all this stuff, what else will we need? If we're trying to prove vertical angles, if we're trying to prove alternate exterior angles, if we're trying to prove all these different types of angles, what other thing might we need that's similar to what we've used in segment congruence? Comes up a lot. Oh, congruency. Yeah. The definition of congruence for angles. Definition of angle congruence. That's what we need. And it's pretty simple. It's almost identical to segment congruence. if an angle has the same measure as another, then they are congruent. All right. How might you see this appear? Well, you might see this. The measure of angle ABC is equal to the measure of angle EFG. And then angle ABC is congruent to angle EFG. That's how you'll see this property used in a proof. Very similar to segment length. It's just saying that if we have the lengths, if we know that the lengths are the same, then we know that they're congruent. This will become more clear why it's relevant once we get into triangles and stuff, because we can't just talk about the lengths of the sides of triangles to prove congruence for that. Yeah. In fact, that's what we're going to be doing for a couple weeks, proving triangle congruence. Or not proving, but using triangle congruence, I guess. It's a better way to put it. Are we going to do this in life? Oh, of course.
Of course, no.
Just like using truth tables to argue with your girlfriend.
She said she used math over the weekend or something for cooking. Yeah.
Yeah, truth tables.
Truth tables. What is up? The truth tables were like the first thing that you guys were like, wait, we're never going to use this. What's up with that?
We're not going to use
Because that was the one we really thought you weren't going to use.
Yeah, I'm dead certain that all the things we've read so far, I'm not using those.
But all first semester, no one said a word about that. But then, yeah.
Because all first semester we didn't care. We care now. Also, I wasn't done writing that.
You're not done?
I just want to know.
All right, are we good? Because this next part is confusing. All right. So, this next part here, I'm going to say this. This exact proof is likely to appear on an exam or quiz.
Exactly that one?
Yes, this exact proof. Proving vertical angles are congruent. That's what we're doing today. Likely to appear. Who knows? So, here's what I want right now. I want you guys to have the given and the proof and this little diagram here, and then we'll start talking.
What does the given say?
The given says lines PT and OI intersect at point L. Point L is here, by the way. I know it's a little weird. That's point L. Yeah. So this is line PT, this is line OI, and they intersect over here at point L. Once you guys have the given and the prove in this little diagram, I'm going to start talking about the statements. You think we got any live viewers?
Absolutely not.
No?
No, you're dead lonely.
You think anyone's in the chat asking questions?
Absolutely no one. Actually, we check right now.
Yeah.
What did the group say?
Yeah, we're streaming live, Nisi.
My kids can't go.
Yeah, I mean, no one can see us, but yeah.
Hello, no one.
There's no cameras on, it's just the screen is being streamed. But
Wait, are our voices recorded?
yeah,
Yeah, they can hear you crazy.
they can do voice recognition. Yeah. Yeah.
What do you want to have written down?
I want you right now just have this stuff, these first two kind of boxes written, and then I'm going to start talking about it. Yeah. We can follow along as we write.
Wait, Mr. What's the YouTube channel?
It's like math. That's a really good question. No, I know what it's called. It was hard to find. It was hard to get to though. So I put a link on Clever. That's the best way to get to it.
So then what's the name of it?
Once you guys have this, I'll show you guys actually. Yeah. It's a good question. I can direct you to it right now. That's good. You can listen to my Honeywine voice at home. Yeah.
And we got that on recording too.
Yeah. Okay. All right, I hope we have a good enough. We're gonna pause this real fast actually because that was a really good question. I want to show you guys how you might access the material. So if we boot up the Clever real quick, this is what your Clever might look like, yeah? I have a bunch of classes. You probably have classes from other periods, right? Like English or whatever. If you go here, there's some stuff here. Here's my YouTube channel. It's got a really weird link though. That's the problem. So like but here's the stuff. And hey, we're currently live. Let's go see what's going on. We're live. One person's watching now. That's us. Yeah, that's us, right? Yeah. 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 You can see here, we got this. Sweet. There you go. Now you know how to get my YouTube channel if you want to.
Open up your YouTube channel. How many subscribers do you have?
Good question. Let's see.
-3. No subscribers.
For some reason, no one seems to care about geometry. I don't know why.
They actually have that.
Wait, there's one person watching. There's one person.
There's views. 4 views.
Poor view.
Wait, look at there's one person watching us.
That's why we can pronounce.
I think it's just bugged. I don't think it's real.
Who the heck is watching this? Get out of here.
Yeah, I don't know why they would watch this on their own time. I'll be honest. Yeah.
The people talking in chat. The people talking in chat.
I don't even know. How do I pull up the chat? Let's see. Chat is disabled. We can enable it. That's kind of funny.
Do it. Enable chat.
I don't remember how to do it though. All right, we're gonna go back. We're basically losing time to do the assignment in class. So, yeah. But yeah, we're doing college geometry, so that's cool. Okay, here we go. All right, so I hope, are we good? Do we have at least this top part? All right. Okay, so our goal right now is this. Our goal, and I'm going to do this in blue, I think. Our goal is this, to prove that this angle here is congruent to this angle here, right? As we know it right now, that's what a vertical angle is, right? Okay. So the way we're going to do that is by using supplementary angles and a couple of properties, because that's all we have at our disposal right now. Once we have proved that vertical angles are congruent, we can use that in a proof, which will make our lives easier, as we'll see in the next proof. So that's what we're proving. So the best way to do that is to find an angle. We want to find an angle that both this angle here and this angle here share that are supplementary. So this angle is supplementary to both of those angles. In other words, angle PLO is also supplementary to OLT, and ILT is supplementary to OLT. So we're going to use that idea and some transitive stuff to prove that vertical angles are actually congruent. So we're going to start with that. We're going to start with the definition of supplementary over here. We're going to start with that angle PLO. Angle PLO, right? Angle PLO plus angle OLT is equal to 180 degrees. That is the definition of supplementary. In other words, this angle here plus this angle here add up to 180 degrees because they're supplementary. Yeah, Jason, what's the question? Yes, I want you guys to have this whole proof down. Yeah. Yeah. By the definition of sup, you could write defin of sup or something like that if you want to. All right. Next thing, I said we need an angle that they have in common that they're also supplementary to. So let's talk about the other stuff. Angle ILT and angle OLT are also supplementary. So angle ILT plus angle OLT is equal to 180 degrees. All right. Okay. So now what we want to do is find some common ground, or something that we have two things that are equal to. We can set two things equal to something, or substitute something. So we're going to do some stuff. The next two steps are subtraction. Any idea as to what we might want to subtract? Can we get one of these angles equal to some two different things? Yeah, Jacob. Subtract OLT? Very, very close, very close. Actually, the opposite. Subtract the thing other than OLT from both of them, and you'll see why in just a second, because we'll get two different things that OLT is equal to. But yeah, very close. That was a good idea. So angle OLT is equal to 180 degrees minus angle PLO. And then angle ILT. Oh, sorry, we subtract angle ILT from both sides, and so we have OLT is equal to 180 degrees minus angle ILT. So in other words, what we did is on line 2 here, we just subtracted angle PLO from both sides. That's how we got to line 4. On line 3 here, we subtracted angle ILT from both sides, and we got line 5. That's what we did. So now lines 4 and 5 have that OLT are equal to these two different things. So because OLT is equal to these two different things, we can use the transitive property. So if OLT is equal to that, and OLT is equal to that, then these two things are also equal to each other. In other words, this is equal to that. Okay, so now we're getting somewhere, right? Our goal, as we remember, is to prove that angle PLO is congruent to angle ILT. Right now, we have PLO and ILT on two different sides of an equation. That's great. We're getting closer. But first, were there any questions on how I did this step here, step 6? Or no? Are we good with that? What is that?
This doesn't really make sense, but you get the letters don't make sense.
The letters don't make sense?
You get the whole thing. It's fine.
Do you see how I took 4 and 5 to get to this? Okay. All right, so now we got to do a little bit of algebraic manipulation. That's it. We're almost there. So subtraction, how can I get closer right now? What can I do to both sides to get closer to this?
180?
Subtract 180 from both sides. Agreed. Let's get rid of that. 180 is gone from both sides. So now we have negative angle PLO is equal to negative angle ILT. All right. And now we need to do some multiplication to get rid of these minus signs, right? All right. Multiply by what? Negative 1, right? So we multiply both sides by negative 1 and we get angle PLO. It's equal to angle ILT, right? So, questions on what I did so far? We good? Yeah, Jason.
Why do we have to do all this when a fifth grader can just tell by looking at that the angles are the same? I'm not wrong.
I could have drawn it incorrectly, right? Good night. Yeah. What if you didn't have that kinesthetic idea, that knowledge? All right. And then finally, because both of these angles are the same measure, then we can say that the angle itself is congruent, right? Boom. We've proven that vertical angles are congruent. Okay. Now there is just one more short proof that we're going to talk about today, and then you're on your own. All right, can I move on, or am I? Okay. Good now, or? Are you good, Jasmine?
Yeah.
Okay. All right. Now we're going to prove that alternate interior angles are congruent. This one's easier. Now that we have that vertical angles are congruent, this one's easier. The more stuff we have, the easier and the more efficient our proofs get. And I think this is the one where we're going to start seeing it a little more. We're going to start seeing it more and more now. This is where second period was kind of like, oh, it's making more sense now. Okay, so as you can see right now, this is a bit of a bare bones proof. We don't even have stuff on our diagram. We don't have numbers. We don't have letters. So, what we're going to do right now is make those. So what I want you guys to do is make a little diagram that looks similar to this. Okay. So the question is, how should we label this? So we are all mathematicians here, right? So we are going to decide how we want to set this up. We're going to use this to construct our proof, so we can decide how we want to do it ourselves, all right? So what's our favorite letter to name a line? X. You want to label it X? What do you think?
L.
L? All right, X, L, and A. Those are the suggestions so far. All right.
Who said A?
So we have line X, we have line L, and we have line A. Because if I just do it like a line like that, it looks like number 1 or something like that. It's trying to distinguish the difference between L and number 1.
All
All
those
right.
are those kind of like that angle.
I don't know, we said, I don't know why.
Yeah.
Okay.
Okay. So that's how we're going to start it out. So right now, what did we just give ourselves? We just gave ourselves. Are we good, guys? Do we need to take a 1 minute break
Yes.
to get it out? Whatever the, we're kind of everywhere right now. Or are we good? We can take 1 minute break. That's okay with me. Yeah.
But then your viewers will have to watch the next minute.
That's very true. Yeah.
Is your
I can't leave my viewers waiting. That's
is
true.
Your, is your
Yeah.
one viewer still there?
We can take a gander. Let's see.
Whenever we get done eating.
This will serve as the 1 minute break, checking the viewer. There's no
Not
viewer.
there.
We lost our viewer. So we lost. Yeah.
What, you have 2 subscribers?
We lost 100% of our viewer base. So
You have 2 subscribers.
I do have 2 subscribers.
If you go up at that rate,
Yeah.
2 subscribers like every 10 minutes.
O'Donnell Math is going viral. Yeah.
Your next milestone should be like 10.
Right here, we question take.
All right.
Okay, so you got another one.
Oh, hell yeah. Okay, guys. All right. So alternate interior angles are talking about 2 parallel lines. So we're going to make them parallel. We're going to say that these lines are parallel. In other words, we're giving ourselves a given, right? We are saying that line X is parallel to line F. That's our given. Thank you for the given. Yeah, Jacob.
Can you put the line over X and L?
Can I put the line? What do you mean?
Like, right, like the symbol, this annotation.
Oh, sure. Yeah. What's the stream called? I just don't know. I only have a link. It's a weird link. I thought it was supposed to be O'Donnell.math, but it didn't really work out. Yeah. What's up, Jason?
I did the math, and the amount of time it would take for you to get 1 million subscribers to say your path is 83,000 hours and 83,333 hours.
So we have a lot of math to do.
Either that or a lot
Yeah.
of waiting.
Yeah. Okay. So, all right. What else did we give ourselves? We also have that line A transverses line X and line L. That's it. Those are our givens. That's what we got. Yeah, Jason. Between the X and the L? That's the perpendicular, or sorry, so parallel lines. Yeah, we're saying that line X and line L are parallel to each other, right? Okay, so to start, so what are we proving though? That's the question. We need to show some kind of alternate interior angle relationship. So let's label some angles. Let's label this one 1, this one 2, and should we put 3 on the right or 3 on the left? On the right? All right. 3, 4, and then down here, well, let's put 5, 6, 7, and 8 down here. Okay. So we've just created a bunch of stuff for ourselves, so we can now prove stuff. That's what we're doing. We're creating ourselves a diagram that we can prove stuff with, right? So out of these angles, which one are alternate interior?
4 and 6.
4 and 6 are alternate interior, also 3 and 5. Which ones do we like better? Which ones do we want to prove? We just have to prove that one of them, 5 and 6?
4 and 6.
4 and 6? We like 4 and 6? All right. So let's prove that angle 4 is congruent to angle 6, right? All right. Okay. So given, we already have our givens. We can say that X is parallel to L, and A blah, 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 blah. Let's just say blah, blah, blah. for now, because we're checking out right now. We want to be done.
So like X, she's formula to line.
So in other words, what are we trying to prove? We're trying to prove this, that this angle here is parallel to this angle here, right? So I'm telling you right now, we need to use corresponding angles somehow. And then we need to use vertical angles somehow. Can we see some progression here? Where we use some corresponding angles, and then we use vertical angles to prove this, to show this. Any thoughts? Yeah, Jacob, what do you think?
Angle 2 is corresponding to angle 6, and angle 2 and angle 4 are vertical angles.
Yeah, exactly. Okay, so Jacob just said angle 6 corresponds to angle 2, right? So we go from 6 over here to 2 up here. Corresponding angles are congruent, and there we can go from 2 to 4 because vertical angles are also congruent. And that's the whole proof pretty much. Okay, so first statement here, corresponding angles. Angle 6 is congruent to angle 2. Fantastic. All right. And now we're saying angle 2 is vertical to angle 4. Angle 2 is also congruent to angle 4. And then by the transitive property, we have what? Angle 6 is congruent to angle 4, right? Yeah. Nice, Dallas. Is that what you said? Sorry. Yeah. Angle 6 congruent to angle 4. And this definition of angle congruence is optional at the end. We are actually talking about the angles themselves and that they're congruent, so we don't actually even need it right now. If we had the measures, if line 4 had the measures, then we'd need it, but right now we don't. Okay, so what do we do right there? Well, we went from angle 6. We said that angle 6 is congruent to angle 2. Angle 6 to angle 2 because they are corresponding. And then we went from angle 2 to angle 4 because they're vertical, right? The transitive property starting from 6 all the way over to 4, right? Yeah, Jacob.
And then does P2 is symmetrical?
Yeah, so that's a really good point. That is another thing. And I said I wouldn't necessarily dock you guys if you guys did this. I did say that. But yeah, we could change this instead of the definition of congruence to symmetric property. Yeah, that's a really good point. If we wanted to make it exact, yeah. To swap them, right? Symmetric property. Good catch, yeah. We did it slightly different in second period. We did end up actually needing that property, but yeah. If you guys want to see how we did it over in second period, we did it slightly differently. No, we don't see it? No? Oh. But yeah, that's it. We're done.
Cool. Thank you.
What's that? Why is it A? Oh. You don't like the way they did it?